Okay, question number 19 from May, June 2016, paper 2, variant 3. We have here a question to do with exponential increase, and this is something kind of newish in the syllabus actually. Now, at the start of an experiment, there are 20,000 bacteria. The number of bacteria increases at a rate of 30% per hour. Work out the number of bacteria after 4 hours. So it's like you start off with 20,000, and then after 1 hour that increases by 30%, and then after another hour that new number increases by 30%, and after another hour that carries on increasing by 30%. So basically you start off with 20,000. Okay, 20,000, and you multiply by 1.3, and that tells you that will increase by 30%, because if you increase by 30%, you've got 100% plus 30%. So it's like if you find 130%, okay, is like adding 30% to 100%. So if you multiply 20,000 by 130%, you are increasing it by 30%. Now 130% is equal to 1.3 as a decimal. Okay, so that will increase 20,000 by 30%. But that number is going to increase again. So that number is the end of the first year, or sorry, first hour. Okay, that's after 1 hour, that's how much it's going to be. After 2 hours, the number is going to increase by 30%. Okay, and then after 3 hours, that number is going to increase by 30%. And after 4 hours, that number is going to increase by 30%. So if you think about what you're doing here, okay, you don't have to go through this big palaver here. If you think about what you're doing here, what you've got is 20,000 multiplied by 1.3 to the power of 4. Okay, some people memorize the formula for this. Okay, the formula is like the new amount, okay, they call it the new value is equal to the original value, which say we call it P, times, and you got 1 plus the rate over 100 to the power of the number of steps that it increases. So that's the starting off value, which is 20,000. The R is going to be 30. So you got 30 over 100, which is 0.3. So 1.3 to the power of the number of times it increases, which is 4. So some people memorize this formula. I personally don't like to memorize formulae. I like to think of the concept. So basically, this is the amount you start with. This is the multiplying factor which causes something to increase. 1.3 increases by 30%, but not once, not twice, not 3 times, but 4 times over 4 hours. It says per hour, and this is for 4 hours. That's 4 steps it's going to increase in. And then to find the answer to that, you simply just plug that into your calculator. So you have 20,000. You have 20,000. 20,000. 1, 2, 3 times 1.3 to the power of, which is this button over here with this x power blank, to the power of 4. That gives us 57,122. So 57,122 is going to be the number of bacteria after 4 hours. Okay, part B says after how many whole hours, in bold type, after how many whole hours from the start of the experiment will the number of bacteria be greater than 1 million? Now again, this is something new in the syllabus. Here we have to use trial and error. We don't have any other method from the syllabus of IGCSE apart from trial and error. So what you do is as follows. Okay, I know that 20,000 times 1.3 to the power of something. I want to know when that first becomes greater than 1 million. When will that number, what number here will cause that this become greater than 1 million? Okay, so all we need to do is try different values of x. So for example, we know that when x is equal to 4, you get 57,122. So obviously it's got to be more than 4. Okay, if I put 4 there, I'm not going to get 1 million. Let's, for example, try 10. It's just trial and error. let's just put 10 instead of the power. So you're going to have, instead of the 4, you're going to put a 10. Okay, so you've got the same thing that we got above. I'm just going to put 10 there, and I'll see that I get 275,717. 275,717. Let's have a look. 717, that's like rounded. Okay. Alright, that's not the correct amount. So let me try, for example, x equals 20, for example. Okay, x equals 20. And we'll see what that gives us. We just replace that 10 with 20. This is just trial and error. So 20. Well, that gives us 3 million. That's too much. 3,800,992. That gives you 3 million. That gives you 3 million and 800,993. 800,993. That's too big. So this was too low, and this is too big. So I need to go somewhere in between. Let me try x equals 15. Let's see what happens when we put x equals 15. So I'm going to take my calculator, I'm going to change that 20 for 15. 15. And that gives me, that looks something sensible. 1,23,717. So that's going to give you 1,102,3717. 3718. 102,3718. Okay, that gives you this value here. Alright, that's when x equals 15. Okay, so it's reached 1 million. Okay, let's see what happens when we put x equals 14, just to make sure it hadn't reached 1 million before that. So okay, that's below, that's 787,000. So we can see that when x equals 14, 787,000. X equals 14, it's 787,000 something, whatever. So we can see here that after 14 whole hours, it hasn't quite reached 1 million. After 15 whole hours, it would have reached 1 million. After you've got to 15 whole hours, it would have already reached 1 million. Somewhere between the 14th and the 15th hour, it reaches 1 million. So after 15 whole hours, it would have definitely reached 1 million. Okay, so it would be more than 1 million by then. Okay, so that is the answer for that question.